Hi, my name's Jay, and I suck at programming. Like a lot of other people, I'm not going to let that stop me. So this is the first of hopefully many tutorials that I have been wanting to do on Node-RED. It is a visual programming tool, works as an excellent teaching aid to learn beginner programming. It's also becoming quite popular among Internet of Things enthusiasts. This particular tutorial will be in response to some questions posed by the user Chris1988 on the Node-RED forums, and I'll be going over flow context variables and the switched node, two very powerful tools to act as a foundational building block for lots of programming possibilities. So now, to start, like most prototype Node-RED flows, we're going to use an inject node that's just able to send data into a data path that will continue on. Usually we'll start with a timestamp just because it's nice and variable and we can see things changing without having to put in a lot of work. It's also good to throw in a debug node that takes output from the flow and throws it over to our debug tab here. This won't do anything yet because nothing's wired together. So what we need to do is take the out of that, draw a line to the in of that, hit deploy, and now they're connected. So if we hit that button on the timestamp inject node, we get output from that side of the debug node. In this case, that is a Unix formatted timestamp. Don't need to go too far into what exactly that means right now, but if you want to, you can look it up and learn a little bit of computing history. One of the nice things with these debug nodes like this is you don't actually have to redeploy the flow every time you change something. So, like, see, every time we click that button, we get output. But if we want to silence that because it's annoying us, we can click that, that'll retract, and that means that it's not sending anything, even though the data actually is flowing. Now, when I said flow context earlier, that's actually referring to a data store for variables that is stored at different levels. There is a node context that's just data that is local to a particular building block. We've got the flow context, which stores variables that are available to anything in a flow. For our purposes today, that's one of these tabs, but it's also it also applies to subflows. They get their own flow context. And then we've got global context, which means those bits of data are available to any flows running on this particular instance of Node-RED. So any other tab can write to it, read from it, and so on. Flow variables can be really nice for doing things like cut and paste work because it's isolated to the flow. As long as you kind of wall everything off into its own flow, you can just use the same variable names over and over, get kind of nice and lazy with it. That's kind of how I like to roll. Now in this case, what we do to set that is we need an input and we need to move that payload into the flow context. So we're going to use a change node that has the ability to do a little bit of data massaging. If you double click that, you get its configuration. So what we're going to do is, in this case, I want to preserve everything all the way through, so we can set and then currently set to set the message.payload to something. But what we're going to do is drop that and set flow dot, we'll just call it thing, to, and then this can be our input. We're going to take the message dot payload from the beginning of that node. So our input message dot payload will be kind of received by this node and then sent out to flow.thing. So hit done there. Wire this up. Wire that up. Get rid of that direct connection because we don't need it anymore. And then if we go over to our context data, this is present as of version 0.19. Just to be able to look at this. However, this did exist in previous versions. You just couldn't call it up and actually look directly at it like this. So if we hit this refresh, nothing pops up. So now let's deploy. Once again, nothing pops up. That just set everything there, kind of baked it. Now you hit this button and doesn't look like anything happened, but if we go over to our debug window, see we're getting traffic. But if you go over here and you refresh our flow context there, we'll notice that the entry thing appeared. So we now have a new field in the flow context called thing, and if we click that, that'll update. We actually have to query this every time. It doesn't auto display. It's changed already, but we haven't looked at it really quite yet. It's kind of like a Schrodinger's cat type of deal. So now we look at that and we see that that's set to that new value. And if we go over here, we can see that that was there a while ago. Now, this becomes particularly valuable when we want to use this with other things. In particular, our example calls for use of the switch node. The question that was posed in the forum by Chris was if we could come up with something that was the equivalent of an electrical relay. This will do the job, although I would probably be more apt to use the analogy of a flow valve in a fluid system as opposed to a relay, because this can actually have more than just two possible outputs. If we go to its configuration here, what we can do is this here line determines what it evaluates on. So we can go drop that down, leave the message space, go to the flow context, and then if we fill in our flow.thing, anytime a message comes in on this side, that node is going to evaluate the current state of thing, no matter what traffic is coming in. It doesn't care what this traffic is. It just cares what flow.thing is. So in this case, we will, let's give it a condition of is true. So if flow.thing equals true, it's going to come out output 1. We can add another output down here. We can set that to is false. And then let's add a third one just for completeness. And we'll set that to be otherwise. So now we've got true, false, and otherwise. When we hit done, we'll notice that that switch node grows. And now we have 3 outputs. One for is true, one for is false, one for otherwise. Now, if we take another debug node here, I'm just gonna copy paste those to duplicate them quickly. We can pipe one to each output and wire anything to that. Hit deploy. And we can pretty much throw this guy out now because we're not actually watching the output of that. We're only using that to set the variable. Some people might have trouble with this because they get so invested in the analogy that this uses of the wires wiring it together, that they think, okay, would you need to wire that together? But no, if that's going to the flow.thing, we've already got that note written over here. So now let's deploy that. Now, since thing is currently set to the value of that timestamp we sent, if we send anything through, go ahead and clear that so we see that, we get some traffic there. But if we highlight that, notice that it highlights our bottom debug node there. That indicates that it came out the otherwise condition. So this switch saw that the thing variable wasn't true, wasn't false, it was something else. So it sent it out there. Now, what if we want to set it to true or false? We can do that with an inject node. Just set a Boolean payload of true and a Boolean payload of false. This could be the equivalent of like a light switch or say a safety override of some sort. Now go ahead and wire that up, deploy. So now let's make this true. And remember, before that had been coming out the bottom here with this otherwise, but now that we've hit true, the timestamp down here, let's clear that out. We've hit true, just to be sure. That timestamp, now that's coming out true. Say we want to go false. Now that's coming out our false. Now say we want to throw random nonsensical data. Now that's coming out the otherwise. And in this case, that could literally be, like I said, anything other than true or false. It could be a timestamp. It could be the word potato for all it cares. It's just something it doesn't recognize. This is why I like to use these otherwise outputs at the bottom of most of my switch nodes, because it lets us know if it's getting data that it doesn't really know how to deal with, which is great for identifying error conditions, or say you fat-fingered something and you're not sure where. It's great for probing out mistakes in your flows. Now, another nice thing about this is this can act as kind of like a valve, but we can go a little bit further. We can actually do other things with this, like say, I'm going to call this light on, and then let's take this one, say that's light off. We can wire those both to the input of our switch, deploy that. Now if we hit true, light on came out the top. That's our true output. Hit light off, that also came out the true output. But if we hit false up here, that now set the flow.thing that this is looking at to false, which this should be coming out the middle now. So light on, and yes, that's coming out the middle output. Light off. Okay. Now, you might say, okay, well, we've got this switch. Why do we care where it's coming out? We can also do things like just completely detach everything from all but one of the outputs. So now in this case, we can hit light on or light off all we want, and nothing's coming out until this condition is true. Then we can hit light on and light off all we want, and that's actually being sent to whatever we want to happen. So now we can go from here and take some action. So let's see. We'll take this change node. And let's say change. Let's do a change. We'll look at the payload this time and search for, if it says let's make that string, not message. If it sees a string that says light on, let's replace that with turning on the lights. That'll represent a thing actually doing that. And then go to change. If the message payload is light off, okay, so now that gets a little bit more advanced. So we've got light on. Oh, it says turning off the lights. We can hit light off. Oh, turning off the lights. But if we hit false, now we get nothing. Or we can take this another step further. And since this one will be false, that we'll call that kind of an overridden state. So we'll put in the message, not allowed to turn on the lights. And not allowed to turn off the lights. Oh, I should have wired that together before I did that. Go ahead and wire that to the same output. So now, if is true, and you hit light on, turning on the lights, turning off the lights, and so on. If it's false, not allowed to turn on the lights, not allowed to turn off the lights. Or we can play with it a little further. Now here's where context starts to get really kind of funky. Let's see. Let's make a third way of doing things on this. Let's make the payload be a string that says auto. Let's add, that's just going to go to the payload. Let's add an extra. If that equals, so once again, if flow.thing equals auto, and that gives us an extra. Now let's take this guy here let's not do that yet. Let's set up another change node here. Set flow dot, we'll call that message stream. Go camel case on that for convention's sake. And we'll set that to whatever our incoming payload is. And now, in this case, now this could be anything. It could be an MQTT topic. It could be an RSS feed. It could be sensor data from a thermometer. It could be really anything. In this case, though, what we're going to do is just have it be let's go every half second. Every half second, this timestamp is going to throw its output into flow.message_stream. So we can kick that off. And if we go over here and refresh our flow.context again, and we can see that's actually updating itself on a fairly consistent basis. But it's not going anywhere that we're actually looking at. So we can go to our switch node here. Let's add a condition, or not a condition really, another output. This is just copied from these guys, so I'm gonna clear this out. We're gonna add a new set message payload to flow dot, what do we call him again? Message stream. Okay. So what we should have here is if flow.thing is true, it's coming out here from here. If flow.thing is false, it's coming out here from over here. And now if flow is auto, anything that comes out here will be changed to what's in message stream. So let's go ahead and deploy that. Go over to debug, clear that out. So say we're true. You know, we can flip our lights on and off. False, it won't let us. Now auto, now we've got our timestamp no matter what we do. So that's just one portion of what can be done with flow context in using it to operate switches. I personally use this for overriding motion detectors. For my lighting, for example, if you walk into a room, it turns the lights on if you hit a motion detector, or if the motion detector senses you, unless you flip a switch and then the motion detectors are temporarily disabled, and this is just part of what we can use to do that. Or you could use something like, say, making two conditions mutually exclusive, like, say, if basement light is on, kitchen light must be off. Or say if the fan is on, you're not allowed to turn the lights on or off, but if the fan is off, you are allowed to turn the lights on or off. You know, it's really kind of all depends on your imagination at that point. All right, well, hopefully that answers questions and gets some brain juices going. If not, I will be here. Enjoy your evening.